Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, I'm Dave Whitehead. Welcome to Schweitzer Drive. Over the last 2 seasons of this podcast, we've covered a wide variety of topics related to science, technology, business, and even the culture that goes into building electric power systems. While discussions have been diverse, there have been a few themes that have emerged, and we're going to cover some of those in other podcasts. But today, I've got a great one. The electric power system is facing some big challenges in the coming years, largely due to what's being called the clean energy transition. My guest for today's discussion is Heather Rosentrater, Senior Vice President of Energy Delivery and Shared Services at Avista. Avista provides electricity to nearly 340,000 customers and natural gas to about 300,000 customers across 30,000 square miles in Washington and northern Idaho and parts of southern and eastern Oregon. The utility provides power to SEL's operation in Pullman, Spokane, Washington, and to our Lewiston, Idaho facility. And not only were we lucky enough to be served by Avista, but we're also a customer to Avista. So Heather, I was doing some math real quick. I think we're buying more of your product than you're buying of our product. So we got to talk after this podcast at some point. Heather is responsible for electric and natural gas engineering operations and shared services at Avista, as well as its human resources, fleet, facilities, and supply chain. She's led the utility's grid innovation, smart grid, and smart city efforts and has a broad experience on both the electrical and natural gas sides of the utility, having managed departments and projects in transmission, distribution, SCADA, as well as asset management. Hi, Heather, and thanks for taking time to join us today.
Hi, Dave. Thank you.
Oh, this is going to be fun. I've been looking forward to this. We've had a lot of podcasts where we talk about the generation side, whether it's hydro. We just did a podcast on nuclear. We've talked about changing loads on the electric system, whether it's cars or just the influx of everything going electric. And now I thought it'd be great. We talk about you guys, the wires that hook all of this stuff up, right, to really make this new electric system that's just spawning and growing. That you guys are the ones that are going to make it happen. So let's jump into this. There's lots of ambitious goals and mandates being driven by concerns over global warming. I've recently saw where Avista filed a plan with the state regulators stating that you plan to serve 80% of your Washington customers with renewable energies beginning this year and increasing 5% every 2 years. Will you talk us through how you be doing that, and how are you balancing cost, reliability, and the environment?
Yes, absolutely. And I think the best place to probably start is the last part of the question, because I think that's one of the biggest challenges we're working through is that balance between we are absolutely committed to that clean energy future and providing sustainable resources to our customers. And we know that we need to do it affordably for our customers and reliably. And we're seeing more severe weather systems coming in, more severe heat events that are causing challenges on our distribution system. And so making sure that we're being very thoughtful when we're making this transition to our clean energy future in ensuring we still have the high reliability that our customers need and expect, you being one of them, as you noted, and affordability, and especially in our service territory. I know this is something that all utilities care about. In our service territory specifically, we have a high portion of vulnerable population of low-income customers, and so we're even more sensitive to ensuring that we create that clean energy future as affordable as possible for them.
For people listening that may or may not realize this, Washington State and in our area, Vista, we're really blessed with an abundance of hydro. Last time I checked, I think technically hydro doesn't count as part of your green portfolio, or does it now?
Well, that is a good question, and that actually uncovers the next part of what I was going to mention when you talk about the 80% and 5% more every 2 years, and that you noted specifically for our Washington customers because of the clean energy transformation initiative that we're required in Washington State to have certain clean energy resources they're supposed to be carbon neutral by 2030 and carbon free by 2045. However, there's a lot of different numbers out there depending on how you slice and dice this in terms of, well, what's carbon neutral, what's carbon free. When you look at Washington specifically versus, as you noted before, Avista serves Washington and Idaho customers on the electric side, and we have our own goals that are actually more aggressive than what Washington has as part of CETA is the acronym they use. And we have our own goals of carbon neutral by 2027 for our entire service territory on the electric side and carbon free by 2045 for our entire system. And so when you look at, well, is hydro considered clean? Yes, it's considered clean if you tie the renewable energy credits with it. So for Avista, we're fortunate to have a large portion of our energy resources as hydro. We also have some solar in our portfolio and wind in our portfolio. And historically, in order to support affordability, we have sold the renewable energy credits associated with those resources to other areas to reduce costs for our existing customers. And the amount of renewable energy credits that we sell actually reduces all of our customers' bills by 1%. So it's material, it's significant to get value. So we have actually, before you consider us what we sell in terms of the renewable energy credits, currently for our entire service territory, Washington and Idaho, we have somewhere in the low 70% that we already would be considered clean before we sell those renewable energy credits. But once we sell those renewable energy credits to support the affordability for our customers, then those resources that we sell the renewable energy credits for aren't considered clean anymore. And so that's where you look at different documents and you see different percentages of, when you're looking at our entire service territory versus Washington, or if you're looking at just the inherent nature of the resources that are, from a physics perspective, probably serving our customers versus what is considered clean when you look at it from a market perspective and being able to sell the renewable energy credits. And so those are just a slice of the complexity that we're working through right now as we move towards those goals that we personally have at Avista for 2027 to have carbon neutral by 2027 for all of our service territory, but then the requirements we have at the state level. And how do we step into those goals and those requirements in a way that are still getting the most value for our customers from an affordability perspective? So that's the puzzle that we're putting together right now.
That's really interesting. And I'm going to learn something here. The engineering side and the physics side, I think I got a pretty good handle on how we generate electricity and how it gets used in different homes or loads or factories and stuff. But now teach me about this. So let's say you can generate 70% from hydro or solar or wind, but you can sell some of those generation credits to somebody else. Could that be somebody in, say, Florida or something? I mean, totally disconnected. So you can sell those things anywhere. Mm-hmm. Now, by selling them, do you by definition then take on, say, non-green energy? And that's what lowers your percentage? Or how does that work? You sold your credits.
Right. And so that's, to date, in Washington and Idaho, we haven't had the same requirements to need to have those pieces, those parts of the generation to be tied to our generation, the same way that maybe a California or another state might have. And so we've been able to sell that attribute of the resource to support lower costs for our customers. Uh-huh. But in the future, because of those legislative requirements in Washington, we need to keep that attribute with the resource to be able to truly call it clean as part of the requirement. So historically, we've been able to separate them. In the future, we need to to be able to consider it as part of that requirement and being clean, we have to keep that renewable energy credit attribute with the actual resource.
What is the credit associated with? Is it associated with, say, a megawatt generated from you from a hydro plant? What is the unit of a credit based on, I guess?
Yeah, and I'm not, in the thick of it on our marketing side. I assume it's in megawatt hours, likely.
That would make sense, right?
Mm-hmm. Yeah.
It's finance and politics, and that's way out of my sphere of excellence. So I got some homework, I guess, after this podcast. How do credits really work for this going forward? But here's the interesting thing. Because I was down in California visiting some customers and some friends. My buddy down there had just bought a new Mustang Mach-E. And I don't know if you've driven an electric car, or certainly a Mach-E, but it was a lot of fun to go driving around. In fact, we get onto a freeway and my buddy goes, punch it. And so I push my foot all the way down and that thing took off. The guys in the back seats, it was like being on a roller coaster. We come over this rise and there's a police officer right there with his radar gun. And all he did was use his hand to show me to slow down. So it would have been ironic, right? I go drive my first electric vehicle, right? And I get a speeding ticket with it. But so it all worked out. But that brings me on to electric vehicles. Southern Cal Edison, I read a report of theirs the other day, and they are predicting a lot of electric vehicles being put into their grid. So much so more that it's really going to affect mainly their distributions, but to some degree their transmission system too. In fact, the interesting thing that popped out of my mind was if everybody starts putting electric vehicles in their garages, what's that going to do to the little transformer in front of my house? They said putting a car in your garage and charging it at peak time is the equivalent of the household load at the same time. And as I recall, like in my neighborhood, there's probably one household transformer for every two houses. So there's going to have to be a lot of build out certainly in the distribution system just to support electric vehicles. Biden administration, lots of folks. I think Inslee here in Washington State said by 2030 we're not going to sell gasoline engines anymore. I think it's somewhere on that timeline. Mm-hmm. What do you see the impact then being to Avista as you guys prepare for what I like to refer to as these mobile loads? And it's interesting. Not only do you have to plan for them during when they're charging at night, but where are they going to drive to and get charged to during the day? So this is, from a forecasting and planning perspective, this has got to be an interesting challenge, a great engineering problem to solve.
Yes, it has been. And I'll say it's something that I've been very interested in for many years. And we actually started pilot programs recognizing the trend and the potential impact, opportunity, and challenges that this kind of adoption could cause our system many years ago. And it's been something I've had on my list to purchase an electric vehicle since I started getting more involved in it. Again, this is 6-7 years ago. And I will say that I purchased my first electric vehicle just a couple months ago. My son became driving age, so he purchased my car, and I bought a little Mini Cooper 2-door EV. And like you said, it is so fun to drive. I just like excuses to go to the store, go get things. And
do you get range anxiety with it?
The only
I heard that's
time
a thing.
I have, yes, exactly. Because it has about 100-mile range, which is fine for most of what we do. But the times that I do get concerned are when I've got, my heated seat on, I've got the heat turned up, the radio on, and it says it's 100 miles, and then I go about 30 miles and it says I only have 50 miles left. That's when I get concerned that things are going faster than expected. But overall, it's been wonderful. I've been super happy with the purchase. But back to, our Avista's interest, and we really see it as an opportunity. It's one of those elusive win-win-win kind of scenarios, because based on what we just talked about, our energy mix on our system and what we serve our customers, we've calculated that it results in about an 80% emission reduction on average for customer that changes from a gas vehicle to an electric vehicle. So there's significant just overall environmental benefits to changing. Just that individual owner themselves, it's a big economic value. It costs less than $1 per gallon equivalent to drive an EV on average. And then we see it as potentially, if done right, and that's why we've focused a lot of pilots and a lot of analysis and work in this area, because we believe if done right, this can provide reduction in rate pressure for all of our customers. Because as we know, our system is designed for that peak day of the hottest day on a hot year. And so most of the time, our distribution system at least has a lot of capacity available, and that's underutilized. And so if we can partner with customers, and we've done several pilots in this way and have found that there seems to be a lot of flexibility with when they charge and openness to doing that. And so if we can partner with our customers to charge in those off-peak times, then we can have higher utilization of existing assets, which can spread those existing costs over more kilowatt hours, and therefore, reducing rate pressure for all of our customers. So we've seen that it has to be done with intention, and there's a lot of work to make sure that that is an outcome versus just having to build a whole bunch of new substations, put in a lot of new transformers in neighborhoods like you were talking about. That is one future if we're not intentional about it. And we hope there's a different future where it actually results in us just utilizing the existing infrastructure that's already out there and being able to partner with customers. So back in 2016, we started our first pilot program to test these assumptions of would customers be okay, programming something versus just plugging in when they get home. And then in really through 2019, we've been working with Washington, our commissions in Washington State, and they've been very supportive of different pilot programs and looking at load management technology and load management programs with our customers to determine if we can make this a win-win-win.
Yeah, and to be fair, my analogy is, you need to replace all the front yard transformers. That'd be the doomsday scenario, right? I think everybody adopts an EV tomorrow, and that's not going to happen, right? The prices of EVs are still pretty expensive, right? They're not for everybody yet, but I imagine at some point that prices will come down on them. And I think probably what's really going to happen is that the predictions are going to be a little bit too aggressive for when the cars get adopted, which will allow the utilities to naturally upgrade their system, as opposed to, you wake up one morning and you have to redo all of, say, our town, Pullman, down here tomorrow with upgraded distribution systems. Mm-hmm. Switching topics just a little bit, let's talk about wildfires. Certainly we live on the West Coast. Washington State's no different, where we have, I think certainly over the last 5 years, we've had a lot of rough fire season. Maybe last year wasn't as bad as the previous years, but it's a big challenge, and they seem to be increasing. What used to feel like we were talking about that something that happened just in July and now August seems to be happening all across the year. We just saw the big firestorm they had down in Colorado a few weeks ago, and that was December. There's a lot going on. Can you tell us how Avista is working to mitigate fire or the risk of fires in our service territory? And will power safety shutoffs be part of your wildfire mitigation plans?
Yeah, the wildfire resiliency is top of mind for us. And I'll say, as long as I've been at the utility for 25 years, wildfire risk has been one of our top risks at the company that we've focused on. And so there's always been a really strong focus on vegetation management and other wildfire resiliency types of activities. However, to your point, over the last few years, there has been much heightened focus on the need to continue to harden our system and to upgrade our vegetation management programs, just based on a few different things, the environment itself and the heat and the drought, making that worse. And then also what they call the WUI areas, the wildland urban interface. So more and more homes being built in those heavily forested areas are causing higher repercussions when we do have, wildfires. And so that's something we pay attention to as well. And what we're seeing in our service territory that's also making it worse is just the health of the forest is deteriorating much more quickly than we've seen in the past. And so based on all of those things coming together and what we've seen, just the impact of some of these really tough fire seasons all around us, and we've experienced them as well, that we've had a focus on creating a more focused wildfire resiliency plan. And so we created one in 2020 that we published, and we've been updating it ever since. We worked with a really broad range of partners, from fire professionals, our state regulators, other utilities, land use agencies, to put together that plan. And we've been working that plan for the last 2 years, really as one of the most high priority things at the company, recognizing the huge impact it can have on our communities.
I've always been impressed with Avista's the way that you guys lay out distribution networks and the selectivity that you can put in it with, different recloser controls and the way you do loops. I know some of your research folks are actually looking to get even more selective on where you turn off, where to reclose or not reclose back, on when a line trips out, because that could have been from fire or a line breaking and perhaps causing a fire. So when I say a distribution feeder or a lateral goes off a distribution line, isolating that if you've identified it as a high risk area and keeping the lights on to as many people as you can in a very safe manner. It's what I've heard from your research folks, and it's really impressive what you're doing. So thank you, since you're my service provider. I appreciate it a lot.
Yeah.
So we talked about your research groups and cool projects you're working on. I'd like to talk about a few of those. You all are one of the founding partners of Urbanova, which is a smart city living lab aimed at designing the cities of the future. Will you provide us an update on where you guys are at with that?
Yeah, we've got some exciting projects going on. And for those that aren't familiar with Urbanova, we see a unique attribute of what we're focused on from a smart city perspective is having it be people-centered, people-centric in terms of the types of projects that we're looking at and how we're involved in the community. And so it is, leveraging data, technology, and new innovation, but it's to solve problems that matter to people, not just because it's cool from a technology perspective, which as an engineer, sometimes I can get off track, and so it needs to be redirected. It needs to be focused on a solution for people. And so we actually just hired a new CEO, which is a big transition. We've had Kim Zentz there since the start of it. And so it seems like we're in a sustainable place now. We've got a lot of great projects going on. We were founded in 2016 and have done some air quality projects with Washington State University, and have also done some work with Gallup in terms of surveying. We surveyed 4,000 residents in our Spokane's East Central neighborhood to understand what are the tensions that they're experiencing, what are the challenges that they're having that a potential smart city project could help. And what we uncovered was that a large portion of them were having, perceptions of safety issues and security issues, specifically around parks. And so we work together. We're actually partnered with Itron and the city of Spokane, Avista, and Urbanova to bring smart technology to a local park in that area to see if we can have, smart lighting, other security types of infrastructure and then we'll survey them afterwards, and see if that actually helped create more sense of community and a sense of security for that neighborhood.
I know you guys are partners with Edo, or you and I think McKinstry created a company called Edo, and you have a handful of buildings, and I forgot what it's called, West Side or West Step.
The South. Well, we were working specifically in the South Landing area.
I wasn't even close, but it sounded really cool. It's like, how do you manage the utility, right? Work with the buildings together to accomplish different goals. I think one of the things, I know maybe there's a little bit of a project down here at WSU where if there was like some stress on the power system, you could send a signal to the buildings. It's like, hey, could you turn off your chiller? These big, there's like a 1.5 megawatt chiller for a handful of times, or turn up the thermostats and we can dump, or get back, say, half a megawatt of power because the demand was, I need 2 megawatts of power from somewhere. And those are really, I thought, that the way you could collaborate between these big buildings that they probably don't care if you turn the chiller off for half an hour or something like that, but as long as you turn it back on. Some really interesting stuff. Maybe you could talk a little bit about what's going on there.
Yeah, it's really exciting. We have several projects, and actually Washington State Department of Commerce has funded several grants that we've successfully been part of. And so we're one of the ones that you might be referencing is a Clean Energy Fund 3 grant that we received and have partnered with Urbanova, Avista, and Washington State University because we've been able to use their buildings in the university district in Spokane to do exactly what you're talking about. And we've installed solar on those buildings. We've installed 2 banks of batteries on those buildings and then have integrated with their building management system, just as you were saying, to be able to make them grid efficient buildings. And, we think about the built environment. For the most part, their building management systems are operating their buildings for the economic benefit and the comfort of their inhabitants. That's their number one goal. Whereas we know that there's, based on the assets they have, and when you add other assets like solar and batteries, there's a lot of flexibility with how they operate, even to keep comfort for the people that are in those buildings. And so when we can share information about, wow, the grid is really congested right now, or prices, from a supply side are incredibly high. Can you, like you said, can we pre-cool or preheat or use some of the battery storage to be able to reduce the congestion on the grid, or to be able to take advantage of price, differences on the supply side? This is another one that can be a benefit for all of our customers if we can optimize how we're operating the grid and how we're using our generation resources more effectively. That can support everyone. And so this Department of Commerce Clean Energy Fund 3 grant is doing that, as well as a more recent one with EDO. And this might be another one that you're talking about with the U.S. Department of Energy. We recently were granted with EDO, with Avista, McKinstry, Pacific Northwest National Labs, and Urbanova, Connected Communities project that also has similar goals in mind and working with the South Landing buildings and assets.
This is a pretty progressive change, if you will, between what the role of a utility was, say, when Edison and Insul were kicking everything off. It was a lot more transactional. They'll create electricity and somebody's going to buy it. And that's, the meter was the demarcation zone for it. And that was about the extent of the relationship between the supplier and the consumer. Do you think this is going to be the future of electricity providers and consumers, of how a product is used and consumed going forward?
Absolutely. I think that our days, and I hear, over the years have heard, gosh, if Edison was alive today, he would say, well, what have you been doing, for the last 130 years, that everything looks the same. But I will say what we're experiencing now is transformational in terms of, how the grid's operated. And I was a distribution planning engineer back many years ago, and I knew the tools we had when we had growth on the system and we were forecasting capacity issues. Our tools were build a new substation, put in a new distribution feeder, change out your transformer. Those were the tools we had to fix the problems. It's so exciting now because we have so many more tools that maybe aren't completely proven or aren't fully mature yet, but we see that through experience and pilots, they will get there. And there's opportunity to have a whole different toolkit to be able to more efficiently, more cost effectively, more sustainably from an environmental perspective, to be able to support future growth with working with these buildings and other large loads that have flexibility to be able to minimize how much, new substations and other infrastructure we're building.
The Catalyst building that opened in 2020 in Spokane's Eco District was another cool project that you guys were involved in. And the goal of it was to be the smartest building ever built. Will you talk a little about some of the cool innovations that went into that building?
Yes, that was fun. And our CEO at the time, Scott Morris, gave us that vision. And he wanted the 5 smartest blocks in the world in this South Landing area, the Catalyst building to be the smartest building. And so as an electric utility, we thought, okay, how, from an electric perspective, how can we ensure that this is as smart as possible? And again, recognizing that the grid itself, the way it has to be built to be able to support customers on that hottest day or coldest day of the year. Again, there's a lot of underutilized assets most of the time. And so that's where we came from, is how can we build buildings that can operate smartly with the grid and ensure that the building users are comfortable and that it's cost effective in how they're running, but also break down that barrier, like you said, between what there's historically always been, this barrier between the grid and the building owner operator and how they're operating their building. And if we can break that down, we can operate both more efficiently. And so with the Catalyst building and then the Scott Morris Center for Energy Innovation, we've created an eco district to be able to get economies of scale. So we're combining the heating system, the electric hubs of both those buildings, and then it's been designed to be able to support 2 more buildings when they're built in the future nearby. So we'll have 4 buildings that are all supported with heating and cooling and electrical infrastructure that's just in the Scott Morris Center for Energy Innovation. So someday when you're up in Spokane, we'll have to get you a tour. It's a pretty cool building to go into and see all of these. They've got thermal tanks to be able to store the heat, the heat and the cool, so that they can preheat and pre-cool. And so we'll be able to test, is having that kind of thermal storage, how does that compare to an electrical battery from a storage perspective, from a cost perspective? And so we'll also have electric batteries, chemical batteries that will be there, as well as we've got solar on both of the buildings. And by having we've got, this DC bus in pulling all of the solar and the battery together. And then we've got, again, all the HVAC all centralized as well. And then being able to have that connected with signals from the grid to be able to charge those batteries or preheat or pre-cool with the thermal storage tanks. It's just really exciting to start exploring how much we can influence the efficiency of the grid, the utilization of the grid, the cost effectiveness for all of our customers.
A long time ago when I was going to engineering school at WSU, and you had to kind of pick what you wanted to specialize in electrical engineering, that junior year. It's like, do I want to design computer type things? Do I want to go into power? What do I want to do? And it's like, I looked at power. It's like, it's 60 hertz. What do you do with it? You turn a light bulb on, you turn a light bulb off. That's the boringest industry you could ever go into. Fast forward to where at a long time, another 40 years from where I was sitting in that room in Sloan or something like that, to what it takes to run, operate, and manage an electric power system these days. This is an exciting field we've got. I mean, I look at a utility, they have to have all kinds of advanced electronics, all kinds of advanced statistical analysis to optimize the utilization of assets. Nobody wants an asset underutilized, right? But at the same time, you have to deal with what happens if a cold front or a high pressure comes in the middle of winter and sits on top of us for 2 weeks. Where are you going to, you can be only so efficient before you need more resources for peaking and everything else. So you have to plan for that. Or like we experienced this summer where it was 110 degrees for, 2 weeks long. It's and how do you manage all this? That's why I'm so excited about it. There are so many opportunities for so many different technologies or people or sciences or what have you, from making smart buildings to running the grid to detecting faults. This is all exciting. So Heather, thank you very much. And hey, tell your boss, tell Dennis hi. It's great him, and thank you guys for supplying us the probably the most reliable electricity anywhere, and gas.
Absolutely. Thank you.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.